special array functions that help construct vectors and matrices filled with specific values at a particular arrangement. They're usually used for different purposes, such as initialization or creating an array with a specific size to use in later calculations. The first one is zeros. It creates one or multidimensional array filled with zeros by using the shape and data type. So let's try it. If we drop the type, so the default type is float. It is important to notice that the shape for 2D arrays should be given as a tuple. That means between parentheses. For example, so as you see here, we constructed a matrix of 5 rows and 6 columns. Now the next type of special arrays is ones. So similarly, if we drop the type, we get float. So the default type is float. Again, similar to zeros, if we want multi-dimensional array, so we have an array of 5 rows and 3 columns of integer ones. The function full fills the array with a fill value, from which it takes the type if the type is not defined. For example, so now we have an array filled with sevens. It is 5 elements and all are integers because we entered 7 as an integer. If we define 7 as a float, so it will be float. Or we can add the type by saying float. Again, if we want multi-dimensional array, we can add it as a tuple. Empty returns an array with arbitrary values. It is used in order to create an array with a specific dimension, but the values are filled randomly by the interpreter. For example, we didn't define 7, it took the last value and filled it with. Again, if we drop the float, same result. We also can create multidimensional empty. So in reality, it is not empty, but it's arbitrary values. It took the last value, for example, from the last number. Let's try integer type. And you see huge number, arbitrary, totally random numbers, just in order to create with a given dimension. Now, to make working with arrays easier, NumPy has Arraylike functions which copy the shape or the dimension from a given array to create a special array. Let's create an array. Let's say A equals to the zero like, we say zeros like A. So it returns an array of zeros with the same dimensions of A. Now, as you see, it copied also the type from A. because a is integer, so it copied the type, but we can change it just by adding the type. Now let's go through the remaining ones quickly. So as you see, all of them work in the same way by creating a new matrix or a new array according to the dimension of a given array. Now, one of the most important matrices in linear algebra is the identity matrix. It is a square matrix, usually, of zeros with ones on the main diagonal. And NumPy has multiple formats or multiple ways to create the identity matrix. The first one, and the simplest one maybe, is identity. Identity requires the dimension n, which is the size n by n, and the type. For example, so as you see, we got an identity matrix of size 5 of integer elements. Now, if we drop the type, we get the default type float. The second function is called I. Notice here we need to type dtype equals. It needs to define the argument by name. If we drop the type, we got a float identity matrix. Now, the second form of I is with number of columns. So we can add the number of columns if the identity matrix is not square. For example, because we gave the number of columns 6, so it added 2 columns to the right. It added 2 more rows under the square identity matrix because the number of rows is 6 while the columns 4. The final form adds the value of k. K is the shift value of the main diagonal. So if it is positive, it goes up or above the main diagonal. If it is negative, goes below the main diagonal. Let's check it. The ones are shifted 2 rows above the main diagonal. If we try negative value, 1 row below the main diagonal.